All right, this is 5.4 over the distributive property. What you're looking at here is a kind of a visual representation here of four groups, and I want you to see these groups as this is the grouping symbol, right? So we have this group, and the group is 2 monkeys and $3 bills, and then this is telling me we have 4 of those groups because that's multiplied by 4. Well, what that really means then is if you were to look at it differently, you would be looking at it as this. Because remember that multiplication by 4 is a repetitive addition. That's what multiplication is. And so I have 4 of these groups being added together. And so if you look at it now, 4 groups, each one of them having 2 monkeys would be 8 monkeys, right? Okay. And then 4 groups of $3 bills would be $12 bills. Now, if I put this back into a little bit of a different terminology here, we could look at it and say, okay, if I looked at this as 2M, 2 monkeys, and I looked at this as 3D, right? I'm just going to take the pictures out and look at it as variables, which is what we're working with. Then what I have then is I have 8 monkeys, remember? And that you could find by taking 4 times 2M, which is 8 monkeys, and then taking 4 separately times 3D, which is 12D, and then you'd still have both those, so you put the addition sign back. What we've done is we've taken each term, each different group, and multiplied it by that number on the exterior of the parentheses or of the grouping symbol. So what the distributive property states is that to multiply a sum or a difference, and by the way, the sum or difference, you notice I put it in parentheses because that's how you get to do addition or subtraction before you do multiplication, is by putting it in a grouping symbol. So to multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside the parentheses. I would suggest that as you do this for a while, you actually just show that by, and a lot of teachers will put them on the top. It doesn't matter whether you put these little arrows on the top or on the bottom, but basically reminding yourself, I have to take both of those terms, 3G is a variable term, 5 is a constant term, multiply them both by 4. So 4 times 3G is 12G. 4 times 5 is 20. And one thing I call it busting it out of jail, because now I don't need the grouping symbol anymore. I can drop the grouping symbol and these things are out of the jail. Okay? Let me go down and do a couple more. I have 9 times negative y. By the way, there's an understood 1 in front of that y, so it's negative 1y. Now I multiply it by 9, it becomes negative 9y. I'm going to do leave change opposite. 9 times negative 4 is negative 36. I'll just do leave change opposite right up front on all that row. 1 negative makes this negative. 2 negatives makes this positive. This time I have 3 terms in there, that's fine. That would become 10y. 1 negative makes this negative, and it becomes negative 6c. And that becomes a 2. Do a couple more. There's an understood 1 behind this negative right there, so it's a negative 1 that I'm distributing through here. We do leave change opposite. So I have a negative 1 times a negative 9, which makes it a positive 9k, and a negative 1 times a negative 7, which makes it a positive 7. The next one I would be taking a negative 2 times 6. That's 1 negative, so it makes it negative. Negative 2 times 5m makes that negative. Next one, leave change opposite. Does it matter that the 7's in the back? No. 7 times 4p is 28b. 7 times negative 1 is negative 7. Leave change opposite. Remember, there's an understood 1. 5 times 8 is 40. 5 times negative 1k is negative 5k. What if you're taking a variable times? That's fine. G times 2 is 2g. G times 7g would be 7g squared, because it'd be 7 times g, and we would group that as a g squared. This negative right here really means the opposite of everything, right? That's one way you could think of it as the opposite of the quantity 9 plus negative 6h. You could also think about it as that negative 1 multiplied by it. That would become a negative 9 and a positive 6h. Leave change opposite. 5 times 4 is 20. 5 times negative 3e is negative 15e. Negative 4 times 2p is negative 8p. Negative 4 times 5 is negative 20. Now we could go through all these and say, remember, this is two terms. The p is the variable, the negative 20 is the constant, and the negative 8 is the coefficient, right? The 20 is the constant. I have to actually move it back over here. The e is the variable, the negative 15 is the coefficient. You have two terms. All right, so one thing about the distributive property is it helps people do math mentally. You can do things much easier if you can break things apart and then put them back together mentally. So, like for example, if I were going to do that first problem, 7 times $9.95 in my head, I mean, think about that algorithm for 9.95 times 7. You have to go 35 and 3 and 63 plus 3 is 66 and 6 and 63 and 69. And then you have to count over two places just to get that $69.65. Okay? We could rewrite this in a way, and eventually you won't have to write it down on paper if you practice it. I could rewrite that $9.95 as a $10 bill minus a nickel. Isn't that still worth $9.95? And if I had 7 of those, I could think about it as 7 $10 bills, which would be $70 minus 35 cents, right? And if I can do that in my head, $70 minus 35 cents is going to be $69.65. And we didn't have to do the ugly algorithm because we learned how to break that into a easier way to see it mentally. So if I analyze that second problem, I could rewrite 103 as 100 plus 3, and then could take that times 13. Well, 13 times 100 is 1,300, or 1,300. 13 times 3 is 39. Add those together and you get 1,339, and we didn't have to do a really difficult algorithm. Remember, these aren't just like a one-size-fits-all. They're how you can think about it mentally. Like on this next one, I would take probably, I would rewrite 19 to be 20 minus 1, and then I would take it times 15. 15 times 20 is 300. 15 times 1 is 15. And then I'm just subtracting 300 minus 15, which is 285. Now, if that doesn't work for you, you could rewrite it as maybe you had a hard time with 15 times 20, so could you write it as 15 times a 10 plus a 10, then minus a 1? Because 15 times 10 is 150, times another 10 is another 150, minus 15. So I'd have 150 and 150. You can probably add those in your head and get 300 minus 15, and you're still at 285. All right, the last one, 18 times 25. Well, I might rewrite that one. I think 25 is a pretty easy one to deal with, right? So I might just go rewriting 18 as 20 minus 2, and then taking it times 25. And maybe you struggle with 25 times 20, so could you write that as a 10 plus a 10 before you do minus 2? If you did that, of course, if you did 25 times 20, you're going to get 500, right? 25 times 2 is 50. Now you're ready to subtract it and you get 450. Or you could do it the other way. 25 times 10 is 250. Plus another 250. Then minus a 50. It doesn't matter. Either way, you're going to get to 450. And are there other ways that you could have split that up? Sure. If you can do 5 times 18 in your head, you could have rewritten the 25 into 20 plus 5 and then taken it times 18. All right, just to finish this up, I kind of want to link it to what we're going to be doing in the future, because you might look at this first one and say, well, I don't need to do the distributive property. And you're right. On the first one, you don't need to do the distributive property because you can do this whole problem. Because inside this parenthesis, you can do 11 minus 2, which will get you 9. Then you would just be doing the problem 5 times 9, which is 45. And it would work out the exact same way if you did it with the distributive property. You'd get 55 minus 10 and that gets you 45. So on that one, you don't need the distributive property, but on the bottom one, you kind of need the distributive property. And let me talk to you about where we're going with this. First of all, I should have done leave change opposite earlier, but these Ks are like terms with these Ks. In other words, they can be actually added together, but right now the 2K is caught inside of what I consider this jail cell. It's separated because it's in the middle of a math problem and it can't be just moved around. Remember how we can use the commutative property for addition and multiplication. So you could switch these two around because that's just an addition problem, right? You could switch the 3 to the other side. That would be the commutative property. But you can't really get those 2Ks separated from the -1 and the 3 right now to get them over with the 4Ks, okay? So if I look at it that way, and I want to get those things together, then I need to be able to get this math problem done. Well, that can't be done because I don't know what K is. So one thing that I can do is I can bust them out of jail with the distributive property. That would turn that into a 6K and that into a -3. Now they're not in jail. I still have this 7 over here and this 4K over here. Now it's a whole bunch of addition. So now I can use the commutative property to get these Ks together. 6K and 4K would match up and become a 10K. And I can also move these constant terms, which match up. They would add together and become a 4. And now what I've done is I've simplified it. So look at that big blue problem compared to what I simplified it to, down to 4 plus 10K. Now I have two terms, right? A constant term of 4, a variable term of 10K where the coefficient is 10 and the variable is K.